According to the Department of Energy, nearly 40% of all energy consumed in the United States is used for heating and cooling commercial buildings. With energy resources dwindling and the growing discussion of climate change, both the government and the code community have developed new energy-efficient standards relating to the construction process. The Energy Policy Act of 2005, EPACT, the Energy Efficiency Act of 2007, and Architecture 2030 are creating greater demands on architects and contractors, particularly as they relate to the performance of the building envelope. Because of these initiatives, code requirements have also been revised. Examples include ASHRAE 90.1 2007, the International Energy Conservation Code or IECC, and state codes such as Title 24 of California. All of these codes and standards are calling for an increase in energy savings of at least 30%, leading to an increasingly more challenging building environment. As an example, to reduce thermal bridging and improve a building envelope's energy efficiency, continuous insulation over steel framing won't be an option. It is the prescribed commercial construction standard by ASHRAE and IECC 2009. Even LEED certification programs for new construction rely on ASHRAE 90.1 as the baseline standard to set a project's energy use benchmark. ACCEL-E steel thermal efficient panels meet or exceed these new requirements and make it easier and faster to accomplish them. That's because the ACCEL-E step wall system provides a more efficient, continuous insulation design, a design that overcomes many of the problems associated with thermal performance found in other wall assemblies, including framing factor, insulation performance, air infiltration, and moisture penetration. And unlike wall assemblies that require multi-step installation processes, the ACCEL-E wall system's unique fusion of cold-formed steel framing and continuous EPS insulation provides superior thermal performance in just one installation step. Additionally, this advanced fusion process eliminates the re-engagement of thermal bridging common with brick ties that penetrate continuous insulation. In fact, the ACCEL-E step wall system makes it easier to fasten any cladding while providing a stronger, more even surface. This video will take a closer look at each of the 4 factors that influence a wall system's thermal performance and how the ACCEL-E step system's advanced design can provide you with a more efficient building envelope solution. Regardless of the framing material, framing members are not good insulators. The traditional approach has been to insulate the cavity between the framing members. But because framing members can transfer heat and cold through thermal conduction, energy loss still occurs as shown in this infrared photo. Considering that over 25% of a wall can be composed of framing without insulation, this thermal transference can be substantial. ACCEL-E panels dramatically reduce this thermal transfer by fusing EPS insulation with specially designed cold-formed steel stud framing, ensuring continuous insulation throughout the wall system. The unique fusion of these materials significantly reduces thermal bridging. This chart shows the impact of the framing factor as it relates to the whole wall R value. As you can see, the effective thermal transfer on traditional steel stud cavity walls is a reduction of the R19 BAT to only R6 as it relates to actual wall assembly performance. But the ACCEL-E step system outperforms this traditional approach by reaching an R value of nearly 3 times that amount. The goal of achieving a 50% energy consumption reduction as outlined in Architecture 2030 can't be accomplished by simply adding more insulation to a wall cavity. That's because, as noted earlier, other factors, including the performance of the insulation, influence a wall system's efficiency. In this example, doubling the amount of insulation in a wall cavity may double its R value, but doubling it again has diminishing returns, raising its R value only slightly. And R value can no longer be relied on as the only measurement for energy efficiency. That's because a product's R value is simply a measurement of thermal resistance. A product's R value, such as in the case of fiberglass insulation, is generally measured where the insulation is thickest. It doesn't account for the compression of the insulation, gapping, shrinking, moisture, and other factors that can occur during installation and over time. Once installed, the integrity of the insulation can be compromised. To create a more reliable method of evaluating energy efficiency, ASHRAE 90.1 2007 and other standards are relying on other thermal requirements. These requirements not only specify R value, but also spell out the maximum assembly U factor, or the measurement of heat transfer through 1 square foot of the wall assembly. Buildings must now meet the more stringent requirements of U factor for their climate zone, something the ACCEL-E step wall system easily accomplishes. As an example, the ASHRAE commercial thermal performance for exterior above-grade framed walls with steel framing for climate zones that make up the majority of the United States is an R13 plus 7.5 inches of continuous insulation and a U factor of 0.064. The ACCEL-E step system exceeds these requirements without the need for additional insulation, delivering a product R value of 19, but an assembly R value of 17, and a U factor of 0.051. Even a wall assembly using R19 batts and 2 inches of continuous insulation can't outperform the thermal performance of the ACCEL-E wall system. And the ACCEL-E system accomplishes it in only one installation step. Additionally, because the framing members of ACCEL-E panels are embedded within the continuous foam insulation, the wall system maintains superior U factor performance even over time without any reduction in value. As mentioned earlier, a wall's thermal efficiency can also be affected by the amount of air that leaks through the wall. This unwanted air infiltration causes a thermal imbalance that increases heat transfer and can account for up to 30% of heating and cooling costs. The product R value of the insulation before installation doesn't account for air movement within the wall assembly. Gapping in the insulation is generally the reason for a loss in thermal efficiency, particularly with batt insulation. Shown here is an example of the degree of loss in R value caused by gapping and compression. Continuous rigid foam insulation has the ability to outperform batt insulation when affected by similar conditions conducive to air infiltration. The rigid continuous EPS insulation of the ACCEL-E step panel, combined with its tight tongue and groove joints between panels, help balance thermal migration, restricting convection by effectively sealing off air infiltration. In addition, each ACCEL-E panel is designed with open cavities to run electrical and plumbing mechanicals, so there is no opportunity for air to breach the system. In fact, as this chart shows, the advanced design of the ACCEL-E wall system easily outperforms the thermal efficiency of a typical fiberglass batt and steel stud assembly. Moisture can also play a significant role in reducing the energy efficiency of a wall system, not to mention causing mold and other problems. That's because thermal performance drops as moisture rises. Moisture can occur inside a wall in a number of ways. One of them is through moisture diffusion caused by vapor pressure from differences in temperature and relative humidity between the interior and exterior walls. The closed-cell, non-porous EPS insulation of the ACCEL-E panel significantly reduces the opportunity for diffusion, providing both air resistance and water resistance. Another way moisture can occur in traditional wall assemblies is exfiltration. In cold weather, exfiltration or condensation inside the wall can occur when warm, humid air from the interior space moves through wall penetrations, such as electrical outlets, to meet the cooler air of the interior wall cavity. Conversely, on warm, humid days, it's the cooler, conditioned air of the interior space that combines with the more humid air inside the wall. As with diffusion, the continuous EPS insulation in ACCEL-E step panels creates an air barrier that stops the air movement from outside the wall system while preventing air movement inside the wall caused by convection loops, thereby reducing any opportunity for moisture. Even if bulk moisture penetrated the rain screen, EPS insulation can dry with no degradation to the material and no loss in energy performance of the wall system. The overall result of the ACCEL-E step wall system's ability to overcome the four major factors that affect a wall's thermal efficiency is an effective R-value performance improvement of up to 60% over commonly used wall assembly materials. Expressed another way, the ACCEL-E step wall system shows exceptional annual energy cost savings potential when compared to 5 commonly used materials in wall assemblies. The savings in this example were based on averages for cities modeled in different climate zones throughout the United States. In addition, the ACCEL-E system's ability to frame and insulate in just one installation step can significantly shorten the construction cycle of a project while simplifying labor scheduling. No other wall system today is better suited to meet the new requirements for thermal performance for above-grade wall systems than ACCEL-E steel thermal efficient panels. Energy efficiency, construction efficiency, and labor efficiency. ACCEL-E steel thermal efficient panels provide the solution you need to meet the new demands for a more efficient building system. For more information, visit our website at www.accele.com.